Okay, Algebra 1, we are jumping into the second section of this chapter, 4.2, Relations and Functions. And so I'm going to let you guys define these, but I'm going to talk about them really quick. So a relation is basically a set of ordered pairs. So that's kind of like where you have an x and a y and an x and a y, and it's a whole bunch of them. The domain are all your x values. The range are all your y values. And a function is a very special type of relation. So that is when each x has exactly one y. And I think why this is confusing for all of us, including myself sometimes, is that we have to be able to tell if a relation is a function. And we'll get into that as we go through today's lesson. Okay, so the first thing that we're going to talk about, and you guys have seen these before, is that there are multiple representations of a relation. So we can take this set of ordered pairs, our relation, and we can express it as a table, a graph, and a mapping diagram. So a table is very simple, and they can be vertical or horizontal. So I'm going to make one of each. We have 1, 2, 3, 4 numbers. So a table would look like this, and then you would put the values in there. So for example, I have 1 and 5, 2 and 3, 3 and 2, and 4 and 1. So that's kind of our table. You can also envision this horizontally, like this one right here. We could do it this way. And then I would have 1 and 5, 2 and 3, 3 and 2, 4 and 1. The order which you put them in the table obviously matters. You have to put the x where the x goes and the y where the y goes. Then as a graph, I mean, these are just plotting points, which you guys are familiar with. Just going to sketch this. So we would have 1 and 5. Right here. We would have 2 and 3. Usually I put a graph here for you guys, I'm sorry. So 1, 2, and then up 1, 2, 3. And then 3 and 2. And we're just, this one's not going to be perfect, and 4 and 1. I think this should have been a line, but it's not. And then a mapping diagram. And a mapping diagram is composed of 2 ovals. Most of the time they don't have a label, but just for your reference, you could put an X and a Y there. And then the thing that's different between a mapping diagram and a table is that, first off, you don't repeat any of the values. So 1, 2, 3, 4. And then in this one, I would have 5, 3, 2, 1. But if there were 2 5s, you wouldn't write it twice. And then the other thing you do is you draw a line, but to match up the ordered pairs. So 1 to 5, 2 to 3, 3 to 2, and 4 to 1. That's your mapping diagram. So there's 3 different ways to express your relations. So the next thing is to be able to find the domain and range. So domain are your x values. The range are your y values. And most of the time you just list them. Okay, so a relation is a set of ordered pairs. The relation can be in the form of a table, graph, or mapping diagram. The domain are the x values, the range are the y values. Just repeating what I just said. So find the domain. So the domain is 3, 4, 5, 6. So we just list them like this, 3, 4, 5, 6. The range is 1, 2, 2, 3, but we don't list, if there's a number that repeats, we don't list it twice. That's the only thing there. The trickiest way that this will get is that you have to remember that when we have a solid line, it is composed of hundreds of little tiny points that form that line. So when you express your range and your domain, your range is going to be your y values and your domain is going to be your x values. So if our x values, if you think about a point here, let's just try to pick one off. So let's pretend this point right here. The coordinates of this are going to be 3 and maybe like 4.6. We're not going to list all those decimals to think about all these different little points. So what we're going to do is we're going to write it as an inequality. So the domain are your x values. So this point to this point, it covers everything in between the 2 and the 7. So we would express this as this right here. Okay, that's your domain. Anything greater than or equal to 2, anything less than or equal to 7. And then your range, let's see if maybe I don't have another highlighter up here. Our range is going to be the opposite on our y-axis. And if you look here, these are the values. So you'd write that as greater than 3 and less than 5. And so that's how we use it to express a solid line. So this is just another example of the mapping diagram. The domain is 7, 5, 2, 0. The range is 3, 6, 7, 10. 3, 6, 7, 10. And you just write them in those little brackets that they use. So we're going to practice some together really quick. The first one, it says find the domain and range of each relation. So the domain, we're going to list -2, -1, 0, 1. The range is 4, 1, 0, and then we're not going to repeat that 4. Number 2, the domain are your x values. 4, -2, -5. 4, -2, -5. The range are the y values, so 5, 6, and 12. Mapping diagram. Again, remember this is your x, this is your y, so your domain is 0, 1, 2, 3. People always ask, do I have to put those squigglies? Yes, so you do need to write them in a bracket. 8, 7, 5, 6. Okay. Number 4, domain is 3, 4, 5 negatives, -3, -4, -5. The range is 10, 11, 12, 13. 10, 11, 12, 13. Okay, so those ones are pretty self-explanatory. Now we're going to get into the ones that are a little bit harder here with the graphs, okay? So focus on first your domain. So we want to pick out the x values. So what I think about is on the x-axis, where are the ends? So 2 to -2, or -2 to +2. So if you go least to greatest, so -2 to 2, you can put the x in there and then do your lines. As long as you go least to greatest. So then the range, do a different color here. You think about the y-axis. So the lowest point on the y-axis would be the 1, and the highest point would be the 4. So this one's going to be 1, and make sure to put the y there, and then to 4. Oops, sorry. Okay, so if you focus on those axes, it helps. So again, on our x, maybe you guys should pause me and try to do this one on your own, and then unpause me and see if you're right. Okay, the domain is your x. So on the x-axis, -3 to 2. Think about it, x is smaller than 2, but greater than or equal to -3. And then the range is going to be on your y. So the lowest point on the y-axis is the 1, and then the highest point is a 3. So this would be 1, y, and 3. As long as you do least to greatest, you can use the inequalities can go the same way every time. Okay, so that's how you do tables, mapping diagrams, and graphs. The last part of this lesson just talks about how can we tell if it's a function or just a relation. And so there's a few different things. A function is where each x value can be paired with only one range value. And the easiest way for me to think about this is to give you an equation. Y equals x plus 4. Okay, so think of x as your domain and y as your range. So why don't we think about this for a second. If you give me the number 2, you put 2 in, you're going to get 6. If you put a 2 in again, are you going to get any other number? And the answer is no, you're still going to get 6. So when you put a 2 in, you're only going to get one y value. There's only one answer to this. And so if you would all of a sudden get, if they would have 2 and a 4 here, that would be wrong. It's not a function. And so that's what you're looking for. And I'm going to kind of give you some examples here. So this one, you put a 2 in, you get a 3. You put a 3 in, you get a 4. You put a 4 in, and you get a 4. Now this is okay, okay? Put a 5 in, and you get a 6. Okay, but then when you go over here, if you put a 6 in and you get a 2, and you put a 6 in and you get a 3, this is not okay. You cannot get different answers for the same x value. So you can't put in a 6 and get a 2 one time and put in a 6 and get a 3 the other time. Then the other thing is this vertical line test. So when I would imagine drawing vertical lines on my graph, I never hit a point or 2 points. But if you envision this here, I hit a point here and a here. So it fails the vertical line test is what it's called. And then the last little part is in a mapping diagram. So a 2 can go to a 4 and a 7 can go to a 4, and this is okay. But you can't have a -6 go to a 7 and a 10. Cannot have 2 different answers. So the same thing here, that same rule applies. So let's look at these. And I think mapping diagrams are and graphs are the easiest way to tell. So I put a -2 and I get a 1. I put a -3 in and I get a 2. I put a -3 in and I get a 3. So here is a problem. You have repeating x's and you put it and you get 2 different answers. So is this a function? No, because -3 has 2 different range values. Okay, what about this one? 4 goes to a 5, 8 goes to a 5, 12 goes, so yes, because every domain, which is your x, has exactly one range. And then this one, well, look at here, I'm failing my vertical line test right here. So no, because it fails the vertical line test. That's all you have to do.